In this screencast on conformational analysis, we're going to be looking at the molecule butane in a Newman projection down the C2, C3 axis. And what we're going to do is, using this software called Spartan, we're going to look at the rotational energy about that axis as this plot. So on the x-axis we have the dihedral angle, and on the y-axis we have the energy in kilojoules per mole. So what I'm going to first do is start rotating the C2, C3 bond. So right now the methyl groups at the 1 and the 4 positions are anti to one another, and this is the lowest energy conformer, as you can see by this circle of the data point here. So as we go up, we're going to see that in addition to this conformer, we have a higher energy conformer here, then we're going to go down to a lower energy one, and then a higher energy one. So total we have 4 conformers for butane that we're interested in. So as we rotate, you can see that the energy in the plot is going up, and when we get to the position here, we have HH, H-methyl eclipsing. And so what we learned for the HH eclipsing, that's about 4 kilojoules per mole. The H-methyl eclipsing, that's about 6. We have 2 of those. So 6 plus 6 is 12, plus 4 is 16 kilojoules per mole of energy penalty when it's in the eclipsing conformation. Then as we continue the rotation, we're going to enter a new dihedral relationship here. And so when we get here, even though it's staggered, there's still an energy penalty because the dihedral angle between the 2 methyl groups is 60, and that's called gauche. So you can see from the energy plot, that's a little bit higher than when the methyl groups are anti. So the gauche energy penalty is 3.8 kilojoules per mole. And so if we continue the rotation, eventually we'll see that the dihedral angle between the methyl groups is 0, and you'll watch the energy in the plot increase to the maximum here. So now we have methyl eclipsing, that's worth 11 kilojoules per mole, and then we have the 4 each for the HH eclipsing, so a total of 19 kilojoules per mole. Again, that's relative to the conformer where the methyl groups are anti to one another. Then as you can see, we keep the rotation. The plot is symmetric, so we're going to get into this other conformer where the methyl groups are gauche to one another in a staggered conformation. We keep rotating. Now we have the 2 methyl groups are eclipsing hydrogens, so here, and then the hydrogen eclipsing. And then we keep our rotation going. We're rotating clockwise here, and then again we're at the anti, where the methyl groups are 180 degrees from one another. So again, in conformational analysis, all the bonds are rotating. So if we watch a movie of that, you can see it rotate back and forth, and then you can see the energy go up and down relative to the staggering versus eclipsed conformations. So in this part of our learnings, we want to be concerned about drawing Newman projections and then estimating the energy penalties of the eclipsing versus the staggered conformation.